and gets used of basic principles of safety instrumented systems, and end with a summary of well-known equipment used today in process plants. The term safety often gets used in the context of occupational safety, namely slips, trips and falls. However, process safety and functional safety have a different focus. Safety is a general term that has been defined as freedom from danger, risk or injury, or freedom from intolerable risk. It's the condition of being protected from harm or any other event which could be considered undesirable. Process safety involves keeping the process under control and keeping hazardous materials inside the pipes and vessels. It's a concern of many different disciplines, including process experts, mechanical, electrical, control and instrumentation, as well as safety professionals. Functional safety is essentially a subset of process safety. When hazards occur, the correct operation of automated equipment, such as sensors, logic solvers and valves, should bring the process to a safe state. Functional safety principles ensure that each hazard is prevented or mitigated by equipment designed with the correct integrity. The need for safety instrumented systems is driven by various factors, not least of which are process industry accidents, such as the one that occurred at Buncefield in 2005. Operators of major accident hazard sites look to reduce the cost of insurance by demonstrating that SIS and other protection layers are well designed and maintained. Standards are a third driver for SIS. Companies and organisations work globally to agree best practices such as IEC 61511, which is the global reference source for specifying, designing and maintaining safety instrumented systems. A study of incidents involving control systems was conducted by the Health and Safety Executive in the United Kingdom, with the first results published in the book Out of Control: Why Control Systems Go Wrong and How to Prevent Failure. Although this is just one study, notice that the hazard owner is effectively responsible for setting requirements, as well as operating, maintaining and modifying an SIS after it has been placed into service. So even if an end user contracts out the design, this research shows that over 80% of problems get introduced either before or after a system is designed and installed. To demonstrate the need for SIS, here's an example. This drawing represents a tank with two level transmitters named LAH, level alarm high, and LAHH, level alarm high high. Each transmitter is connected to separate logic solvers, one for basic process control, BPCS, the other for safety, SIS. If it's functioning correctly, the BPCS logic solver can take an action at the level alarm high trip point to close valve CV1 before an overfill occurs. The system responds differently in the case of some specific faults that the functional safety standards call dangerous failures. For instance, if valve CV1 is motor operated, a loss of power will mean it will not respond even if a correct signal is received from the BPCS. However, the function from sensor LAHH through the SIS logic solver to separate valve XV1 is completely independent, and the spring-actuated valve will stop the flow into the tank even on complete power loss. This is the basic principle of independence in protection layers that the IEC series of standards highly recommends for achieving functional safety integrity. You may already know types of SIS by another name, such as the examples here on the left. For some people, the term system often historically referred to just the logic solver element. However, it's important to remember that the safety instrumented system in IEC 61511 includes all the field equipment as well as the logic solvers. Many other types of protection layer can be used to reduce risk in process plants. These are commonly given the term Independent Protection Layer, or IPL. A SIF is one form of IPL that uses instrumentation. Non-instrumented IPLs can be very effective and reliable when correctly designed for a given hazard. However, non-instrumented IPLs, such as mechanical relief valves, are not subject to the detailed SIL requirements of IEC 61511 and are therefore not assigned SIL targets.